In this little video, I'm going to show you how to use a spreadsheet, either Calc from LibreOffice or Microsoft Excel or Google Sheets to solve an equation f of x equal to 0 by the successive approximations given by the Newton's method, which is normally taught in Calculus 1. So we learn in Calculus 1 that if we have an equation f of x equals 0, and we start at some point x0, if we keep doing the sequence, this one, xn plus 1 equals xn minus f of xn or f prime of xn, then this sequence is going to converge under some given conditions to the closest solution of the equation f of x equals 0. That means the point where the graph of the curve intersects the x-axis. For this, in order to understand this equation, it is very simple. At the point x0 and f of x0, you take the tangent line, and we find its x-intercept. And you find, we're going to call this x-intercept xn minus xn plus 1, which is going to be our next point of the sequence, x1. And then I keep doing it. So to start this, let's give the simplest example there is. Let's solve the equation x squared minus 2 equals 0, which is going to give us, of course, the square root of 2. For this, we're going to start with some number. It does not matter what number we're putting in. And in here, we're going to write a formula which gives us exactly the next term in the sequence. This is going to be our x0, this is going to be our x1. So to write this formula in Calc of LibreOffice or in any other spreadsheet, you have to start with an equal sign. And then we're going to write the formula, which is this one, but we're going to use the name of this cell, which is D6 for the value xn, for the value of our variable. So here is the formula. You have d6 minus d6 squared minus 2, that is f of d6, over 2 times d6, which is the derivative of the function x squared minus 2. Now, in order to finish this, what I need to do is to understand a concept from all the spreadsheets, which is autofill. If I'm writing a formula containing, like in this case, the name of a cell, this name of the cell has a relative address. So this is E6. What I'm telling this guy is to take D6, which is one cell to the left, and do these computations with it. If I'm using this handle, which appears in all the major spreadsheets, and extend this formula down the column, which is autofill, well, what we're obtaining here is the same thing, but in this cell E7, we have the same formula, but using the number that was supposed to be here. And then similarly down the road, this is the same formula with D8 and so on. So how do we do this? It's very simple. In this cell, we're going to say that we should put the number that is one cell to the right and one up in there. So equals E6. So now all you have to do is to extend this formula down, because in this cell, to take the value of this guy, xn, is going to become the number here, and we're going to apply the formula to it, and so on. And as you can see, just by dragging this little square, we extend the formula down the road, and we obtain pretty simply the value of square root of 2. Now, the big thing that Newton's method shows us is that it doesn't matter much where we start. You can start, for example, at 10, and although all these values are going to change, the sequence will still stabilize around the 1.414213597, which is a good approximation of the square root of 2. Let's try another example. This time, let's take a more complicated function. Say this function. We're taking the equation x cubed plus 2x squared plus 3x plus 1 equal to 0. Well, if you plug in a 0 in it, we get that f of 0 is a 1. If you plug a negative 1 in it, we're going to get that minus 1 plus 2 minus 3 plus 1 equals negative 1. So this equation definitely has an a solution between minus 1 and 1, because it is negative of one endpoint and is positive at the other endpoint. So what do I need to do now? So this is the formula for our function. This, the formula for our derivative. And let's start with a number. Let's say we're starting with negative 0.5. Let's put it in here. Negative 0.5. So in here, we're supposed to write the formula that gives us the xn minus f of xn over f prime of xn. So with a copy and paste of what I prepared earlier, that is the formula. So this is h6, that's this number, minus h6 cubed plus 2h6 squared plus 3h6 plus 1. All this in a parenthesis divided by 3h6 squared plus 4h6 plus 3. Now simply, in this cell, we say we take this value one cell up, one cell down. And this formula, which says take one up, one to the right, one up, this formula gets extended down. And this formula gets copied down there. We can see that after a few steps, the number has been stabilizing. So minus negative 0.30159709 is the best solution we can have for this, the best solution we can have for this equation. Well, let's say that you don't believe me. I'm going to put this number in this cell, it's 26, so it's negative 0.430159,709. And here is the formula for our f of x. Which says we take this number and we do x cubed plus 2x squared plus 3x plus 1. And now you see we're getting a very small value for f of x. It is 3.5 times 10 to the minus 12. So f of this x is close to 0 to approximately 3 trillionths. Which means that, yes, we got a pretty good solution. So that is the end of this Newton method.